Assalamualaikum and hello. My name is Muhammad Alfiaikal bin Saiful Nihar, and me and my group mate, Nurul Fakir Hausna, will be presenting our report for the PID drawing. My two other group mates are one Aina Maisara and Nurul Atika Haisha. For the introduction of our PID drawing, redrawing a process and instrumentation diagram or PID for a biodiesel plant involves using a PID controller which combines proportional, integral and derivative modes for feedback control. The PID controller is a powerful and versatile method that can be applied to various industries like metallurgy, chemical processing, food production and oil refining. Tuning the three crucial parameters of the PID controller allows for precise control actions tailored to specific requirements and challenges. When dealing with PID control, it is important to consider key control, load disturbance, sensor noises, process uncertainty, and reference signals. Taking these factors into account ensures accurate and reliable control actions, leading to improved system efficiency and overall performance. Alright, so these are the PID drawing of a biodiesel power plant that my group members have put up together. As shown, there are three vessels which are VE201, VE202 and VE203 and T209 as the storage tank. And these are the symbols for each and every symbols and lines for the drawing. Okay, so now we are going to tell about the process description of our drawing. So first of all, the piping instrumentation diagram of the biodiesel plant involves the representation of equipment, vessels, tanks and valves along with their piping systems. The breakdown of the description of each process for the vessels and tanks are as follows. Okay, first off, the VE201 or the reaction vessel. First of all, this vessel transesterification reaction takes place, converting vegetable oil into the biodiesel. Feedstock and catalysts are mixed and heated into VE201. Agitator ensures proper mixing. As a simple explanation, this is where biomass is first introduced into the biodiesel plant to undergo reaction and to go further processing. Secondly is VE202, the separation vessel. Mixture from reaction from VE201 is transferred to VE202 for separation process. Gravity-based separation occurs with biodiesel floating on top and glycerin settling at the bottom. Internal components in the vessel enhance the separation efficiency. Okay, the last vessel in our drawing is VE203 or the purification vessel. After the separation process has been done in VE202, the purification process is done at VE203, where biodiesel from VE202 is transferred to VE203, and the purification process such as washing and filtering are performed to remove impurities. For the tank in our drawing is the TE209 or the storage tank. After the biodiesel from VE203 has been purified, it is stored in T209. Level indicators in the tank monitors the biodiesel level in the tank. And lastly, the biodiesel remains stored until it is ready for transportation or further processing. That is all for the process description. Let's go to the next slide.
Next, I will continue for the lines and equipment. From the picture, we can saw a vessel VE201 that transferring to VE202. The purple line stand for palm oil pipeline, and we can saw at the VE202 we have a AV227, which is actually a actuator valve which convert a control signal into a mechanical motion. And next we have a pump P202, which is a centrifugal pump that use a revolving impeller to add to the force and pressure to the fluids. Next, for the transferring VE203 to tank 209, we have a line. Purple line stands for CPO, which is palm oil pipeline, and the red line stand for steam, the blue line stand for water. And here we have a AV237 that actually a actuator valve that convert a control signal from the control room into a mechanical motion in the plant. Next, we have a P203A, which is actually a side channel pump. The power of a star-shaped impeller rotating concentrically in a casing is transferred to the fluid. Next, we have a AV236, which is stand for actuator valve 2, which convert a control signal into a mechanical motion. Then we have a rectangle, a square device, which is we call it as a heat exchanger. This heat exchanger is called HE203, and the function of the heat exchanger is actually to transfer heat from one medium to another through conductive and convective heat transfer. And that's all from me. Thank you.
Alright, now I will tell about the control loop of the PID system. Alright, so the control loop in the biodiesel plant uses sensors, controllers, actuator and feedback mechanisms to regulate and maintain desired conditions. Sensor measure variables, controller generate control signals, and actuators adjust variables. Feedback ensures adjustment based on deviations. Control strategies include temperature, flow, level, and pressure control, along with safety systems. Operators can monitor and interact with the system through a human-machine interface. The control loop ensures consistent production, efficiency, quality, and safety. Alright, to regulate the control loop in a biodiesel plant involves adjusting parameters for desired process conditions. Methods including set point adjustment, which are modifying the desired values or set points for parameters like temperature or flow rate, manually or through automated control systems. Secondly is proportional integral derivative control, utilizing P proportional, I integral, and D which is derivative terms to calculate control signals based on measured values and set points, allowing for immediate response. Steady state error elimination and oscillation jumping. Okay, so third is tuning parameters, which are adjusting the control algorithm parameters such as gain or integral time for stability and responsiveness manually or using automated tuning algorithms. Fourth is the cascade control, by employing multiple control loops where one loop's output controls the set point for another, minimizing interactions between process variables for improved performance. And lastly, the feed-forward control, which anticipating disturbance by measuring related parameters and applying appropriate corrections in advance to maintain stable conditions. Lastly is doing safety overrides, by implementing emergency shutdowns or activating safety interlocks in a more abnormal or hazardous situation to ensure plant and personal safety. That is all for control loop.
We continue for the safety. First of all, the company should provide a PPE or known as personal protective equipment because it able to minimize the exposure to hazard and give protection that can cause a serious workplace injuries and illness to the employee or a worker. Second, to operate machine, we should have a guide from a competent person because a competent person usually have accurate through training, qualification, or experience, the knowledge and the skill to carry out the task to avoid any accident from happens. Third, the company should provide instruction, training, and supervision to the worker or the employee. As example, how to correct use of guarding and other countermeasures, how to safely access and operate the plant, how to carry out the inspection, shutdown, cleaning, repairing, and maintenance at the plant. Last but not least, the company should provide a warning sign and a caution sign as shown in the picture. It is important because it have to ensure all the safety warning device, guarding, operational control, emergency stop are used in accordance with instruction and information provided.
Alright, so that is all from us. Thank you.